morning, everybody. Thank you to Ken for inviting me to speak at this event. This is a nice opportunity to not go into the office. Although I have to say, 2 p.m. lunch is a little late, but just. So, my name is Jason Quixel. I am a State Work Zone engineer for TDOT, and if you all don't know what State Work Zone engineer does, you're not alone. A lot of people at Tennessee don't know that either. I get asked that all the time at work. What do you do? But in general, my role encompasses the policy, the standards, plan reviews of our work zones, and implementation of new technology, which I'll be talking about today. So the challenges to work zone safety, from a design and planning perspective and implementation, really comes down to 4 basic points. It's communication, it's clarity, consistency, and consideration. Communication. Are you as a driver getting the messages, picking up on what we're throwing down, right? There are a variety of ways that we can communicate our message, but when 3,000 vehicles are traveling in 1 hour on a piece of roadway through Nashville, at 2 p.m. when they're pothole patching, how many know about that work at the time? And when did they find out? Did they find out 5 miles away? Did they find out in the morning? Did they find out 3 miles, 1 mile? Or are they just now, or do they find out when they're seeing those brake lights? Clarity. We need to make sure the message you're getting, you understand what we're saying. I've seen messages on some of our TMC boards where, it says there's road work ahead at exit 205 or what have you. And I didn't know what exit 205 was. Do you understand what they're trying to say? Consistency, and no matter the work and the work zone, the type of work we're doing, are we doing it in the same way every time? TDOT has a lot of different, we have contractors, we have our internal forces, we have private contractors, we have utilities. We have all sorts of folks that want to do work, need to do work on our roadways. And regardless of that, regardless of what the contract says, are we doing it the same way every time? You as a driver, it shouldn't matter if it's a gas company, if it's TDOT, whoever it is, you need to be getting your warnings, your alerts in the same way every time. And finally, consideration, and this falls on us as designers, is have we as a department realized all the effects that this work is going to have on you, the driver? So, and why is this important? Well, statistically, work zones are about 20% more dangerous than a typical stretch of roadway. And that's overall roadways, Of the 40,000 annual traffic deaths, approximately 1,000 of those die in work zones. But work zones make a small fraction of our total miles of road, obviously. So, but from TDOT's perspective, the work zone traffic deaths are skewed heavily along our roadways that we are directly responsible for, as over 50% of all work zone fatalities occur along our interstates and freeways. And of those, rear end collisions, or end of queue, as we will commonly say, are the number 1 cause of work zone fatalities, and they make up about 40% of our interstate work zone fatalities. So, about a quarter of all the work zone fatalities in a year are caused by end of queue collisions. So that's the challenge, so what do we do about it? Okay, well, we protect the queue. That's a phrase you might have heard. We have bumper stickers I think we've made. We have policy for it, We need to mitigate the risk, right? We look at when we're planning projects, we look at we have some very high quality data sources now. We can look at RIDIS data. We can look at hourly traffic sensors. We can review crash data. We can identify what the effects that our proposed work is going to potentially have. When we're trying to figure out how we're going to mitigate that risk, the simplest solution is usually just to restrict the work hours, to work at night or weekends, or to choose an accelerated schedule to get the work done faster, to reduce the impact on our public and on our workers. But when that can't be done, it just comes down to communication once again, right? There's tools such as public outreach, your TV, your radio, your Instagrams. But the most important communication that us as drivers get as we approach a work zone that is causing impacts is that on real-time, on-site alert to that imminent situation. We need to know that it's happening right now, and we need to know where. So how do we do that? Well, we have static signs that we all see, our advanced warning signs, our changeable message signs. But those can largely be taken for granted. We've all seen an array of orange signs that are along a common stretch of roadway you might travel every day, and it's up for 3-4 months, maybe a year, maybe 2 years. So you don't associate that with if you drive through it every day and there's any delays as a cause of that, then you start to assume that there's never going to be. Changeable message signs are the same way. Road work from this date to this date, expect delays. Well, that's great, but if it doesn't happen, we don't trust it, right? So that's where our queue protection vehicles come in, our queue protection techniques. These are intended as accurate warnings and effective warnings to an active work zone's impact, a queue, traffic backup. Traditionally, we've used what we call queue trucks, which is and I'm on the wrong screen, sorry. And we use queue trucks, which are those little guys up there. They are manned vehicles. They're intended to be mobile, to move throughout the day, throughout their shift. They have a message board on them, flashing lights. I think some of them have a soft serve ice cream. I don't know, I've heard. It's expensive though now, but they're effective. They do get, whenever you're approaching a work zone, if you see a police officer or a vehicle like this, we tend to realize that they wouldn't be out there for no reason, and we're probably going to slow down, we're going to pay attention. So these are effective tools as long as you're seeing them. The problem with these is, first of all, they're expensive, and that cost is always an issue. They run about, our average bid price for these is $1,500 a day, which is a work shift. So to properly manage a 24-hour lane closure, we probably need about 3 trucks. So that could run $4,500 per day, per direction. That's not nothing. Secondly, they're not always so reliable. These are large vehicles. They are instructed to sit, half mile to 3/4 mile at the end of a queue and to maintain that distance. Well, we all know though that the queue changes, right? So that is part of the challenge. So these vehicles are expected to relocate as needed. Well, restrictions with shoulder widths, other objects along the shoulder make that impossible. So that's why we will also employ a second truck at times to assist them so they can leapfrog each other. But even then, it's difficult for them to keep that distance. So if you're anything like me, whenever you've seen these vehicles in years past, you are as likely to have seen them out of position as in position. And that's been an issue that we're always trying to get our hands around, So, we have so it's effective, but it's not perfect. So we've been trying new technologies that are more effective and can hopefully, provide safer work zones. So I'm just going to we did have the opportunity where we had, and this was just pure luck, really, that thankfully I identified. We had 2 identical projects a year apart. They were 2 miles apart. They were within 6 days of duration with each other. One was 42 days, one was 48 days of lane closure, daily queues, and the only difference was we managed them with different queue protection techniques. So It was done in Cumberland County, Tennessee. It's located between Crossville and Knoxville, for those of you that don't know. ADT is about 35,000 vehicles per day, trains rolling, and about 36% via trucks. The projects were about a year apart, almost identically. One was February to March of 2020, the other was April, June of 2021. Again, within 2 miles of each other. Both had about 40 days of 24-hour lane closures, and both projects were bridge repair, for what it's worth. They were very short work zones, per se. They were less than 500 feet of lane closure, but the impacts were still fairly severe. For the first project in 2020, it was over Daddy's Creek, and we used one changeable message sign that was positioned 3 miles upstream from the taper point. That message was a static message. I believe it said road work ahead 3 miles. Q trucks, we deployed one Q truck in each direction, for each direction. It was deployed 24 hours a day in each direction of closure. Daily maximum queues we saw were about 5 miles at maximum. They're in that 3 to 5 mile range. And as I said before, the unreliability of these vehicles, we often saw these trucks out of position, where you'd be sitting in the queue and for 10 minutes or something, and then you would encounter your queue protection vehicle, obviously serving no safety benefit to our work zone at that point, as we were already stopped. As you see on here, you can see there was a big cluster. It was westbound where the biggest cluster was. We reviewed all the crashes. We knew there were a lot of crashes on this project. It got our attention immediately where there was a problem. We found 41 total crashes during the, 42 days. Of those crashes, however, we went in and did a little deeper dive for this comparison. We looked at which crashes did we think were attributable in any way to the work zone. So most of those, you could read the synopsis of the crash report, and it would say traffic stopped unexpectedly, rear end collision, angle collision, whatever. But it was usually very clear that it was caused by, the other times it was raining and someone got a flat tire or just ran off the hydroplane or something like that. But so 26 crashes we found were directly related to the work zone impacts. So that was 63% of all the wrecks during there. And we had 10 injuries. No fatalities, but there were 10 injuries, which is, near 50% of all the crashes resulted in an injury, which is extremely high. So the second project, again, it was 2 miles east of this location. There were 24-hour lane closures, April to June of 21. But this one, we managed queues without queue trucks at all. We use smart work zone technology. What is smart work zone technology? I'll tell you. We deployed a series of message boards and traffic sensors. These message boards had an array of messages that they would give. So whenever it was free flow traffic, if you drove through there at midnight, it would just say road work ahead. About noon every day, traffic would start to queue up. And at that point, it would either say traffic ahead, traffic slow, or traffic stopped ahead. And then it would also, in addition to that, it would give a second message as to what distance it was to that slow down or stop condition. So they would, because of the array, we had sensors every quarter mile or every half mile, and we had message boards about every mile. So the message boards could be accurate within a half mile of the slowed or stopped condition. So what happened with here? Well, actually, we saw more crashes. In total, it was a little longer of a project. Well, I'll show you. It was about a week longer. There were 52 crashes, but when we did the deeper dive, we found that only 16 of those had anything to do with the work zone. There was a lot of bad weather that was going on along this time as well, very heavy rains, and that attributed to a lot of these crashes. A lot of them were at night. So only 30% of the total crashes had occurred through here. So it was really a more dangerous work zone, but we saw less work zone related crashes. So only 30% of the crashes were related to work zone activity. And we saw that we had 2 injuries, both were very minor. So just as a comparison on this, again, the Daddy's Creek was 42 days of total closure. The State Route 1 was 48. 26 verse 16. When you work out the crash rate on this, it was half. It was twice as safe, basically. For total crashes, and of course for injuries, it was a factor of 5. So it was a big improvement. Now, recently, TDOT has, we tried to beef up our we really have been enjoying these smart work zones, but we wanted to kind of take it up a notch. So we went with zipper merge. Okay, so there was a project up in Anderson County, that's north of Knoxville. It was a 2-week duration. It started in May, we just had it, and ADT was $55,000 about. Now for this one, it was the same type of setup except for the zipper merge function, which in the last mile, when traffic begins to queue up, the messages, rather than warn you to the slow traffic ahead, they instruct vehicles to occupy both lanes of traffic, and then at the merge point to take turns. Now this one has there's a little video that goes along with this one, so I don't know if I click this, it's going to work. We did some public outreach on this because this was the first time we'd ever expected this. Obviously we are expecting a slightly different behavior than what we know people generally do in work zones, which is to get over as soon as you can. So we had a little outreach. Our public information office put this video together, which also talked about smart work zone technology. Okay, so when we deployed this system, reports from the field were that it worked very well. We expected queues to actually be in the 12-mile range. The issue with this section of 75, it's coming out of Knoxville, is that there's no alternate route. If you have to take that to where you're coming or going from, there's really no good state route or major route to go to. So we didn't get a lot of diversion. We didn't expect to. We saw that the queues actually were much less than that. We had our queue system set up, I think, over 10 miles in both directions. We had many signs and sensors, and saw queues were less than 10 miles every day, about 7 miles. So that's the advantage that the zipper merge has. We're using more storage of the roadway rather than everybody being in one line. We're hoping they use the 2 lanes, and also hopefully it reduces the speed differential between the lanes, where you don't want to have somebody zipping by in one. And so we're hoping to more harmoniously reduce speeds and everyone work together to get where they're going safely. So what we saw 7 crashes during the first phase, 9 days, which was most of the project. Only 5 of those were related to the work zone, 3 northbound, 2 southbound, and there was one injury crash on this, which I think was fairly serious. Someone in the morning was coming southbound it was a Friday, they were coming into Knoxville, and just they'd missed the multiple messages and collided, had an end of queue collision. So, but overall, we found that this was a very positive tool, and we're going to continue using it. We have plans to do another one soon. So the advantages of this smart queue warning, why is this more effective? As I said before, queue trucks are 1 or maybe 2 warnings total at most. And when you're in heavy traffic, it's possible you might get a heavy truck traffic. It might be obscured. You might not even see that warning. Whereas smart technology provides multiple. We set it up right. We can provide multiple warnings for drivers. Smart technology adjusts quickly. They give the relative distance as to the changing conditions, whereas queue trucks are a little slow to react. Smart technology is not affected by restrictions on the roadway, such as narrow shoulders, debris, construction equipment, or material. The challenge of smart work zone technology, it requires good data. We need to know before we set this system up how far traffic is likely to back up, and then be more conservative even to that. We want to plan for the worst, because we don't want to have to deploy the queue trucks on top of this. We want this to be the only tool that warns drivers. The second one is, and this is still, part of the public outreach, is that drivers might not know, to you driving through a smart work zone, you may not realize that that message you're getting is real time. The message boards look identical to the ones that, that you see at a football game or whatever. Just say road work ahead. You might not realize that that is an accurate message. So we're still working on ways to better communicate the power, the accuracy of that information. And then finally, in this Anderson County job, the bid price we received for Q trucks on this was $1,800 and $1,850 a day for a Q truck. We didn't use any, but that's the bid price. So had we used Q trucks to manage this queue, we would have spent $11,000 a day. Whereas the bid price for the portable queue warning system, which we did implement, was $6,600. So 60% savings. So that's pretty good, The bosses like hearing that it's cheaper as well as more effective. The safety is nice. Cost is good. And finally, we were able to get some drone footage of this. So you can see it's not perfect. We would have preferred, there would be folks in both lanes up to this. This is taken starting right at the merge point. So that's all I have. So thank you very much.